Hello everyone, welcome to another live stream. Hi the Lycan, hi the generic person, hi the Antistic Panzer, hi. Hi there. Hi and welcome, and today we will be, well, working obviously. we will be working, and yeah, let's get to it, I suppose. No point in waiting. Where did we finish off animations wise? We were doing the quantum field theory, correct? If I'm not mistaken. Yes, we were doing quantum field theory and... Oh goodness gracious me, where are we actually with the quantum field theory? I remember we just filled in the photons, which means... There's the repair job, even though with asking that question, how could that happen? I mean, how could they interact at a distance like that? Oh, never mind. We just filled in the bingo and then we need to move the camera back where it was. Alright, splendid. Render. Okay, so where did we finish off with this as well? Oh yeah, higher generations. They work in the exact specific same way as particles on the same level, except they just have more energy. And then, wait, is it just Higgs now? I suppose it would be just Higgs. It would be just Higgs. In the club we all found. How are you all doing on this fine day, by the way? How is it going for all of you? The title lured me in. Yeah, I'm scripting the Higgs segment. Hold on, I need to play my music. Oh, I can feel just... The day is afternooning at this point. You know what? I agree. It's just ironic travel the same way gambling is a time traveler trap. What's that even supposed to mean? Higgs, okay. Actually, we could... First we're gonna do Wikipedia. Boson. Then we're going to do library texts. And then we're going to do Internet Archive. The three horsemen of research. I'm gonna try whatever mess you make it. Well, don't say that publicly, Remco. We need to keep up the pretenses, you know. Physics. Okay. Do we even have a Higgs boson here? Can I just say Higgs? Oh, they changed the icons for conceptual college and university. That's nice. Chapter 64. Right here we just have bosons. Ah, jeez. Yeah, that's what worries me. I'm kind of worried that all of these will be just incredibly short summaries. John Gamma is betting on where the electron is around the nucleus. Quantum mechanics. I'm sorry, hold on. Whoa, I don't... give me a second. I'm too sober for this. What? I am way too sober for this. You know what? I'm gonna make a list. I have an idea. We're gonna make a list of everything we need to do today. This means you're not drunk enough for quantum mechanics. Hey, listen. I hear you, Ash. I'm fixing that. Now, a random name picker. Wheel of Fortune. And Sorrow. Alright. What we're gonna have. What's on the agenda today? Agenda? I thought we didn't have agenda. Okay, it's going to be Higgs research, Higgs script segment, then final segment atom script, record particle physics. In the meantime, we're gonna be animating, by the way. Make it please don't be blue or red, please. Wait, I don't actually know if that's to me. The next line has make it. That's a different comment. Mickey's got a little list. I have a lot of different lists. I have a list of my enemies, for example. I have a list of different torturous instruments I'm gonna subject them to. I have a lot of little lists, you know? Well, not that little. About the Higgs. I don't want to be more confused. Okay, particle physics. For particle physics video, we're going to be rendering in the background all the time, so that's just gonna stay there. Then LED big animation, because that's the one last animation I have for that chapter of that video. Speaking of that video, so pick music for segment 4. I get what that means. You all just don't worry about it. Then what we need is write down segment 2, but not script, that's the difference. Then we need script the... Then we need to script the chem physics video, yes, in its entirety, because I really need to. Yes, particle is an extension of the Higgs field, there we go. That's such a, by the way, that is such a brilliant way to describe what some kind of particle is. Because it's not restricted to particles. Hey, make it. Hey, make it. What actually is coffee? Well, coffee is just an excitation in the coffee field. Everywhere in the universe, you just have a field of coffee. It's a complex field, and just excites at points where there is coffee, and it's just flat at points where there isn't coffee. I'm thinking much about the map. I understand that Higgs field has like non-zero value that has something to do with vacuum and potential or something, because objects have certain inertia to them. Like a soup slowing down balls. Like I don't think you're eating soup correctly. Field of coffee spiking not locally. Am I spillest in position right now? Every single time you say like something with quantum mechanics, it reminds me of quantum mechanics. Which is a sentence that I promise makes sense. Anti-coffee. Chemfix video, yeah. And that's it actually. That's all I'm gonna do this stream. That's it. There is more I could do, but I don't wanna add it too much. Spin that wheel! What am I gonna get? Script the chemistry physics video. On it, chief. Alright. What do we have? Okay, the first chapter was already done, right? Yeah. Then hybrid orbitals. So far, then on this we have wave packets. Actually, Remco, quick question. When you have two wave functions on the same field, what process do you use specifically to describe both wave functions as a single wave function? Do you get what I mean? Did I say that properly? Give me a second. Addition. You just add them. That's it. Oh goodness gracious me. All right. Okay then. Okay. Destructively. Simple as it could be. This means that if you start with two wave functions, then if you bring them closer together, actually, I was thinking on the topic, got in. Like there's no stokes for spinners. Like I'm just constantly going back to the one thing. Lycan has a stage 4 Stokes syndrome. Hi the cats, yeah I do it. If you start two wave functions, if you bring them closer together, you end up with two new possibilities for these wave functions. Ah, damn it, bringing in molecular orbital theory. Who would have thought that just explaining molecular orbital theory using exclusively quantum mechanics and no chemistry could get a bit tedious? It's Pauli exclusion. Wait, hold on. Because I can figure this out. Okay. Hear ye. Basically, we have first wave function, second, right? They come together. They just collide head on. They come together and they create. Well, there are two things they can create. They can either create this wave function or they can create this wave function. Not exactly as I drew it, but close enough. Now, the reason why... Hold on, how am I... What would... Okay, there's only one question remaining now. What would two electrons on the same orbital... Okay, Remco, I know it's hyper-specific as a question, so if there isn't an answer you can give me, I understand. But what... Is there a visible difference between the same wave function with just a different spin value? Yes, okay, that's good then. That's really good. They have something to do with something called Grassman number or some shit. They have something to do with invariance. No, Lycan, Grassman. That's what your dealer was saying when you were explaining it to them. They were just, telling you Grassman. Common misconception among mathematicians.
You should go back to sleep, my kid. That joke is even below my fucking pay grade.
It makes sense for Lycan, because Lycan does maths and smokes a shit ton of weed. But I don't know if you can capture it in a 2D plane. Okay, but like, what would that difference be? Crossmanian. See, they called me a madman when I just said that mathematicians are high all the time. And then Grassmanian algebra. Don't know. That's not a great sign. That's not a great sign. How do different values of spin affect the wave functions of electrons? Leptons could be more than whatever. Leptons, right? Yeah, no, because when is that? That's leptons. Simple. We actually wait. This is actually kind of. This is not bad actually, because all of the terms are still there except for the one we care about, which is good. That's actually good news. If I can't find anything better, this already could be worse. All right. No, that's chemistry. Damn it. Hi there, Uncle.
Greetings.
Hi.
I'll just quickly. Well, can you rephrase your question? I'll be gone after I answer the question because I'm doing stuff.
Oh, basically, quick. It's basically how is there a visible way in which the spin affects the wave function?
Oh, the spin.
Yes.
I was thinking about the. Oh fuck.
Yeah. The fourth one, the one that has two options for electrons.
Mm-hmm. Oh, that's a good one. I was thinking about the L, the quantum number, whatever how it's called. In that case, I don't know. I don't think so.
Shit.
Because I think you only need it in normalization where you get like a factor over 2s plus 1.
Okay, but like this equation, right?
Hold up, let me see where you are.
This is a
Which equation?
This is a cat. This is a cat.
Cat.
Let's see.
You did cat.
The complete wave function must contain both spatial and spin components. Refer to the complete one electron orbital as spin orbital, and in general form for this orbital this. What is sigma s?
Probably just the spin orbital, the spin components. That is probably a Pauli matrix.
Okay.
No, it isn't.
Never mind.
What the hell? Why would you use that notation? Hold up, but I need spin component. Because if this is a numerical factor, then we're good. If this is actually a function of something, then we're not good.
Only contact is face change. Goodness gracious me, like it. Lycan, please take your pills. I beg you.
Yeah, no. You will have spin coupling. And this is bad because it makes the wave function way more complicated. Hey, I have good news. We're back to spiners.
Great news.
What?
Can I say something? My daddy secret. I don't know what spiners are.
Yeah, me either.
I don't know what they are. I just never.
Hmm.
I've seen some of them. I just never bothered to actually look into what they are.
There are just some factors that just have two subspaces.
Them spiners.
What the hell? Ah, yes, this is what I was looking for. Give me the wave function. Wave function is... Yeah, they're different.
That's good. What's the difference?
So you want the... I don't like that question. Oh, what the fuck does this mean?
Hold on, over there, did you have an equation a bit higher up? Did you have the equation for the wave function? Did I say that right?
Yeah.
Okay, hold on.
These two. Or these two.
Is
These two are fine.
wait, which one is the spin? Is it the phi? No.
No, it's in the plus. This is the wave function for spin up.
Okay.
This is the wave function for spin down.
Okay, so it's L minus 1.
Yeah. In the spherical harmonics.
But
Yes.
the fucking spherical harmonics. No. Oh wait, no. The root is also negative. Never mind. That's something I could theoretically
Yeah, but
take to the
listen
bank.
this one. Oh wait, the root is still negative.
Okay. Because fuck me, I'm not doing spherical harmonics. Wait, hold on. May I screenshot this?
But like, yeah, of course. But like also the minus signs. This is a plus sign. This is a minus sign. It's not just like everything is different. This whole factor.
Yeah, exactly. It's so basically. Wait, so why is L minus 1 over there? Whilst right here, L. Oh, wait, what's happening to the L? Oh, I think it changes the relation L has to M. Hold on. Because I screenshotted in a way where your cursor was over a minus perfectly in the middle, which made it look like a plus.
You can screenshot these two.
Okay, I think I've got it. This.
Yeah.
Which means.
Yes. Oh, but we're not done. Because the R also depends on spin.
Yeah, but that can piss off.
I found it. The R depends. What is the difference? Oh, A and B. You know what? This makes me scared. What even is going
Make it,
on?
what the fuck, that was a question, I've never seen it before, make it. Oh, this is basically like, imagine if, imagine mathematicians who like really like circles and round things. This is the mathematics they would do. It's just for people who really like round things.
I like round things. Do I count?
Not that kind of round things, no. Okay.
And by that round, I mean broccoli. Brussels. I know what are you for though.
Have your Brussels sprouts. Okay, that actually made me laugh. Hold on.
What, the Brussels?
No, the what Lycan said is just.
Oh.
Lexi don't exist, which probably explain why I love my imaginary girlfriend so much. Also make it. I imagine in my head that these are two sentences and ends after make it. I found a way to make imaginary girls 3D. I use quaternions. Fucking idiotic is what it is. It is idiotic. I shouldn't have laughed at. I don't like the fact I laughed at that. It's funny, but
You're silly.
okay, right here. Quaternion son or geometric algebra daughter. Oh. Start with mental breakdown.
What's up with the fanboys in chat?
What?
Yeah, we brought attracting them with mathematics. No, I just.
Always been like that. Are you new to here?
Oh, Remco! Right now, by the way, making animation, which I'm adding the second field.
Ooh,
Yeah, indeed.
I want to see when it is done. I figured I don't like the wave function of hydrogen atoms anymore. To be fair, I never liked it.
It's too practical.
Yeah, it's too chemistry for me.
Yeah, we need a wave function of an electron in an empty universe. That's much better. And we need a wave function of an electron in an isolated system with absolutely nothing else. And even that's too practical.
I agree. I don't even think we need a wave function at all. Like, just consider the vacuum. I don't use wave functions anymore because everything is done in second quantization where you just use the creation and annihilation operators. So for me, it's very easy to like consider a particle because I just say like, hey, field. Okay, I use creation operator. Now I have a particle in the field. I don't care about wave functions. Where is my wave function?
Okay, delete this. Right here, this will be our cyclic time. This entire thing is our field. Ah, piss! I just banged my knee. Okay.
Just a name, what the hell?
Okay, then at the end we will need. There we go, and this should in fact now allow us to
Well.
actually
Huh.
right here this will be our electron field. Well, this one will be EM field. EM field.
It only now hits me that the solution we're after, the wave function we're after, is the solution of the Dirac equation.
This. I'm just gonna do right here. Like this. Oh, I can! That's brilliant!
Well.
Separate X, Y, Z, and then. Yes! Mixed color.
What the fuck is this?
General social drag equation. There's 4. Hold on.
Alright, so these two.
I couldn't help
the
but
first
notice
two-
that there's NKM. There are 3 quantum numbers.
Yeah. The whole issue with spin is that it's not a quantum number, but it's like part of the spinor.
Oh, okay.
So in this case,
Oh,
this
fucking
spinor,
spin.
is spin up and spin down. It is two elements. And both of these elements, the spin up has two components, and the spin down has two components. And this is like the whole, we have a matrix in a matrix or a vector in a vector. So the whole difference that comes to your problem is the difference between how these two functions behave compared to how these two functions behave. Because the top two are spin up, the bottom two are spin down.
Okay.
Which is not entirely true because they also can mix and then you get a superposition of up and down. And then you're kind of crying. Oh, look, it's very easy. You only need Laguerre polynomials.
I can't even pronounce that. Hold on. Oh, they look way different.
Yeah, but I don't understand any of this.
Oh my goodness. Oh no, wait, they don't. Never mind. I mean, they are, but like, shut up.
I mean, only the normalization constants are difficult, and the appearance. Wait, no, the K is over here. Okay, so when K equals N, we get maybe something we can draw. I think your question is too complex. Don't ask questions again.
Brilliant.
Ah, I found it. The visualizations. It wasn't that hard. What is
Go.
the stuff? So which one did you want to visualize?
I wanted to.
Any show in particular?
No, I just wanted to, because later on, hold on, let me actually remember. Oh yeah, I was trying to do it for the two wave functions coming together, and I had to justify why all of them wouldn't be able to fit on the same orbital, which means that I needed the Pauli exclusion principle, which means I needed two electrons with the same spin, and then I needed two electrons with different spin.
I don't think you can visualize that.
It's not.
I mean, maybe you should have started with that question.
But that's the question I started with. Yeah, is there a way for me, like, is there a visible, I do believe the exact question I asked was, is there a visible change to the wave function depending on the spin?
Yes, that is.
What is it?
But like not with the wave functions you're plotting, not with the wave packages.
Yeah, but still, what is it? Because I can work around that then. I can pull it off somehow.
Yeah, it's what's on my screen right now. These are the different ways when you consider different spins.
Okay, so hold on, hydrogen like atom.
So from up going down, I believe you change your spin.
Hydrogen like.
Never mind, you don't change your spin.
Okay, so in this case, wait, you don't change your spin in this case actually. This doesn't change. This is the same orbital for the same spin.
I have no clue actually what they're doing here. Let me think about this, if you can apply something. What you want is...
Oh, I could have actually done it a pretty elegant way. Nah, too late. Happens. EM field. Oh, I'm too consistent. EM field function. Okay, and then in this case we want to start with no particles.
I suppose the main difference is what you could use is that the energy is different. That is, if this is spin. If S is spin here.
Oh, I just crushed my blender. That's brilliant. Was it different?
Well, let me fact check this, but I think the energy might be different. In which case, in your animation, the amplitude would be different.
Oh, that would be brilliant. I was expecting something way more difficult. If that's the case, that would be really good.
I would say do that and put an asterisk. Energy depends on the spin.
Okay, now how do I slice this cake? What else will I need? If I decrease it way further down, what's it gonna look like? Compelling. Remco, wanna see how I'm gonna visualize electrons repelling each other?
Yes,
Right, let me know what you're watching.
I'm watching.
The problem is that it's oscillating a specific way, so it looks like the photon is traveling quicker one way. I need to
Yes.
figure out how to fix that.
Also, I feel like this is a source of infinite energy. Considering the photons are not, or like the electrons are not like moving away from each other.
Yeah, but in this case, if I just move them away, there's not gonna be an infinite loop. And right now, I just wanted to show you the basic idea.
Yes, I like that.
This is what I'll have to show, that the virtual photon doesn't specifically come from one of them to the other, but it does travel between them from one to the other. That doesn't make any fucking sense.
I think you don't want to show it like straight back to back. You might want to show first the first case, photon from one electron to the other, and then the other way around.
Oh no, because right now I am in the video just talking about particle physics. Virtual field, because it happens, which means they need another field. The electromagnetic field covers the electromagnetic interaction. So this is just like me showing the action of them repelling, but this is not them actually yet repelling because they're still standing still. And the reason why it's bouncing back and forth is because, well, I'm trying to show off the dimensions.
Oh, that works, yeah.
Virtual photon.
No, I see what you mean now.
In this case, if I...
All right. My final conclusion is we don't have a wave function for anything higher than hydrogen. So hydrogen only has one electron, so there you don't have to talk about the second electron. So I have We don't know how if it depends on how it depends on spin. From what I
Brilliant.
gather.
Good, good. It's really bad for me. I'm just gonna, in that case, I'm just gonna label them with saying that one of them has spin up, the other one has spin down.
Yes.
It's like a warning label. Be careful. This electron has spin up. This. Another field. Okay, splendid. This will be the electromagnetic field that we'll use to mediate the electromagnetic interaction. I'm talking about it as if I'm creating a universe. Yeah, this is the field we'll use to mediate the electromagnetic interaction.
Yes, you are creating the universe.
Alright, brilliant. Now, where was I? Oh, yes, scripting the video. Value my sanity. I doubt it, Ash. I very much doubt it. No, but speaking of, actually just reminded me, we'll need to find some time today to, as a trio, study quantum mechanics.
The helium atom cannot be solved exactly. Thank you.
Oh, live text, my beloved.
Absolutely useless.
No, we won't study wedge products, Ash. We won't study wedge products. But we can study quantum mechanics. Functions.
Yeah, no, I have no clue. The difference in how the wave function behaves is complicated.
This lower energy. And this wave function, which is higher. Now, if we only have two, well, I think you anyway, because this, at least this reassured me. This is good.
Is it though?
Yeah, I'll manage.
I believe in you. I will go back to studying though.
Good luck
So
studying.
good luck with the stream.
Have a good one.
Ciao, ciao.
See ya. Change the volume from that difference of lemon and not me of voting such. Where's we do the air product definition of the star? Oh yeah, for now, see ya. Alright, like and bye. Have a good one. Have a good one. Answering function. Only have two possibilities. abilities are wave functions. We only have the possibilities for wave functions. That means that means the fucking obvious. It means it can either be the first one or the second one. And one of them requires more energy. It means that both of our wave packets will much rather interfere this way, creating new hybrid wave function. Now, this is simple enough, but what if we have 4 particles? What then? The most mathematician response. It's been real. No! Nothing is real! Then, well, if we have 4 particles, once again, they come together and form this shape, whilst the other 2 form this shape. Why? Of them form the non-interfering simple shape. Why must form 2 different shapes and divide themselves into groups of 2? Oh, why that is, I ponder. And wouldn't this be a perfect segue to poly-exclusion principle? In which case, poly-exclusion principle, tool very much created, invented, and cared for by the particle physicists, and then just completely abandoned for the sake of chemists. I know, don't get me wrong, I know as in physics poly-exclusion is still a big deal, but physicists don't have the rights when it comes to the usage. It's incredible. The cornerstone of chemistry. The only thing is real is my Wi-Fi for university is not, so I can do something other when I'm studying for a change. A will. That's his will. Here's my will for you, so I can study something other when I'm studying for a change. Yeah. I'm really glad, Ash, that you're finally going to the uni, because I've been as someone who has been here since like the very beginning when you were worried that you wouldn't even be able to go to this kind of university. I'm just really happy to. Back then I did say that you could pull it off, and you did pull it off, because I'm always right. I don't mean to do my own horn, but I did say you could pull it off, and you did pull it off. So add that to the basket of times Make It was right. Happy for you, Make It. Make a video on my research paper when I deliberately write one. That is the rule. That is the rule. Yeah. So far, I've only been able to do it with Flame, but listen, when you all write your papers, I'm gonna make videos on it. Pauli exclusion principle. Exclusion principle. And what it states is simple. Damn it! Once again, I have a question for Remco. Because I need to make sure that I understand the Pauli exclusion principle correctly. If I don't, this is going to be quite a pain. Praising like I should, I have to praise. Like I should. Okay, you know what? I'm gonna leave this for now because in this case, in order to continue, I really need to clarify with Remco if my understanding of the Pauli exclusion principle is correct. Because in this case, it would be the half spin. Switch the particles and they're not the same, right? Cassie, you're in the voice chat. Why you? Whatever. I won't even. You feline. Okay, now. Spin that wheel. Final segment atom script. That is funny enough something I can do before I do the Higgs. Simply because it won't be quite as relevant. So, atom. So, would like to finish this video off with a bang. Finish it off with something incredible. Beyond Katsi eating's ASMR? No. No. You know what? Fair point. I stand corrected, egg on my face. I think really ties together particle physics into our real life. And that would be the... Actually, I could even go for helium. Ooh, hold on. 1 hydrogen. Okay, so just 1 right? 1 hydrogen decay. I am specifically interested in... No, deuterium, right? I'm specifically interested in this decay, however. Okay, the Pauli exclusion and this mathematically is because Fermion wave functions are antisymmetric, something like that. And if the two are the same state, the wave function is trivially zero. Yeah, so that's what I'm saying. When you like swap the electrons around, you get a different wave function, despite them being theoretically identical, because they're not identical. Okay. The same wave function but opposite signature. See, that's exactly why I would rather wait for Remco with this, because I'm gonna say a lot of things that are close to being accurate but not close enough. It's just, it has to decay. It can do it slowly, but it's not a proton. Subject to beta decay. proton if that occurs. Okay, tritium, fine. In this case, it decays into helium. Oh, sorry, what now? I'm sorry, what now? Neutron to proton. Oh yeah, no, that does make sense. Wait, why is this 3-2? Oh, because 3... Huh? 3-2, wait. Because tritium starts with 1 proton, 3 neutrons. If one of the neutrons decays into a proton, shouldn't that be 2 just helium? 1 neutron. Oh no, tritium has 2, I'm an idiot. Oh my goodness, tritium has 2 neutrons, not 3. Okay, yeah. This finished rendering. Now particle physics, back to it, photon. Elementary, you have already filled in the electron. I think it's not photons. This time you can directly field hierarchy because the repulsion happens because of electromagnetism, which means that what we need is another field. The electromagnetic field carries the electromagnetic interaction, and the reason why they repel at a distance is because in these electromagnetic fields where the repulsion happens. Effectively, the ignition starts with one of the electrons causing an excitation at the electromagnetic field. Alright, gotcha. Now right here, let's do 41 to 80. And in this case, couple of changes. First things first, I would like the color to be more pronounced, which means we need to multiply it before the hyperbolic tangent. Multiply it by like 5. And that should make the color more pronounced as we increase the particles. Then we're going to clear the keyframes for now. Give it its time, and then go from 0 to a 1. There we go. This could be a bit too narrow, actually. Might be a bit tough to see. Yeah, this should be fine. There we go. Oh, but first, damn it, it's always something. It's absolutely always something. We first need to render the loop. Hi, Theo. Okay, so what we're going to have in the final chapter will be... That would be tritium decay. So, let's start with our fields. Those will be the up quark field, the down quark field, the electron field, the neutrino field, the strong field, the electromagnetic field, finally the weak field. And as far as I'm aware, oh, it could be weak. Do we need weak W and weak Z, or do we just need the weak one of them? Beta happens with the W, but do we have anything else that's going to happen? No, there shouldn't be. Easier. And now let's have a look at, let's add the particles. We first start with the nucleus, whatever. It's nucleus, mostly fine. So 2 up quarks and a single down quark. This will be our proton. Then, in order to this would result in hydrogen, but since we're interested in the isotope, we need to add 2 neutrons, which means on the sides we add 2 down quarks and 1 up quark on the left and right. These will be our nucleons, and right away as do we also want to add the electrons? In what order do we want to do that? If we were to kickstart our universe, a couple of things would happen. First of all, these quarks would become confined, and they would instantly begin exchanging gluons, actually forming the subatomic particles, like so. Next, next what? What next? Next, photons.
Well,
Yep. Tritium has 1 electron still, right? Oh, how nice this is, because this also decays into an electron. How convenient. For subatomic particles like so. Next, we have the electromagnetic field. And since... Oh, what does charge look like on the electromagnetic field? Is it still a photon? Because it can't be a virtual photon. There is no place for the virtual photon to go. I mean, technically, I guess there would be, simply because it would be exchanging between quarks. This might be an asterisk spot, because this would be quite annoying to model. Right, you would need to assume a completely empty universe with an overall positive charge, which is not something, as far as I'm aware, not something that happens in our universe. Every interaction kind of conserves charge. Okay. So this is gonna be a bit of an asterisk. And since our quarks do have charge, we get excitations on the electromagnetic field. We get some photons. Now, overall, our charge is more positive, which means we would like to attract something with negative charge, something like an electron. And right here we're going to have the electron just clouded. This electron is confined to the nucleus. Well, not confined, because it is stuck to the nucleus via the electromagnetic interaction. Action keeps it in place. Go. Swell. This is what a tritium atom looks like from the perspective of particle physics in 1 dimension, of course. there is a reason I picked tritium, and that's because of it's really unstable. So if we really want to experience particle physics, should also look at its decay. It's one of the upquarks. Wait, upquarks? No, downquarks. Downquarks decays into an upquark. Or more specifically, it decays into an upquark and a minus W boson. Thus conserve all of the properties in our 2 neutrons, 1 proton hydrogen into a 2 proton, 1 neutron helium isotope. Then on the other side we get W boson, which in itself also really wants to decay. This time into anti-electron neutrino and an electron, correct? Anti-electron neutrino and then... yeah. Electron neutrino and an electron. Immediately comes together with the already existing, nicely balancing the charge. Hold on, I just... give me a second. Charge of our atom, keeping it from becoming an ion. The anti-neutrino just floats away. It isn't stuck to our atom via the strong interaction or the weak interaction or the electromagnetic. Just going forever. And so there we go. That's our atom. Back on it, there is a lot going on. A lot of things, a lot of waves. But by now, it should all be perfectly understandable. This is the full standard model at play. The best description of the universe we have so far, and a complete overview of all the forces. And gravity. Despite being the force most well known to everyone, I've left gravity last, even after the Higgs boson. And that's because its carrier particle, the graviton, is a whole other story. Not only is it hypothetical, also it has some fundamental problems with just the theory. Problems I'm not even qualified to talk about. So that's why, right here, bring in my own.
That's why we use someone Ramco to have him talk instead.
That's exactly it. I bring in my own personal physics expert, the master of gravity. Relative. Hold on. Let me just. Yeah.
Are you gonna have? Or should have Ramco have his own fucking Blender model?
I haven't thought of how. I mean, I have thought about how I'm gonna represent Remco, but I don't really have an idea yet. I would need something. I'm gonna figure it out.
Do you want something funny?
Worst case scenario, I'll figure it out.
Okay.
I need something purple.
No, not much. Big an eggplant.
Go. Represent Remco as a government boy. In first place. You got first place for that comment.
Or
Brilliant. Good for you. You know what? Good for you. Who might stop you?
I mean, you aren't wrong. That's what Ramco basically is.
Supreme. How am I? was trying to work on some puns. Of space and.
Of course, a pansexual would say that.
Shut up. Same thing. The. Excitation, the drunk fuel. It's Remco, and then Remco's gonna say something, and instantly I'm gonna cut him off. Like, actually, you know what, Remco? I don't have time. We don't have time for this. It'd be so funny if he said something like, it's great that I'm in the video today because I actually have a theory that I think explains gravity.
Oh my god. Please, no.
Perfectly. And unifies relativity.
So fucking stupid.
That is, and then oh, sorry.
Poor Ramco.
It seems like out of time. Whoops, and then that will be just the end. Space time.
Meow.
Expanding. Lord of Space and Times. They're the same thing. Actually, no, Master of Tale Expanding should be next. That has a much nicer rhythm. No, same thing. The Master of Tale Expanding. Excitation in the Drunk Field. It's Remco. Yeah, there we go. Now all I need to do is just the Higgs, and that's it. So there.
Wow,
Yeah, and then the
we're
phone
literally
will be-
done.
Well,
Oh my god,
the
you work
script.
fast.
Then I need to record the video. Then I need to. Oh, speaking of, it's just not on the record video. But in order for me to record video, I need to do the research on the Higgs, and then need on the to, and then I need to
Well, you have to wheel, but you still have to do them in order.
Well, yes. Well, I mean, yeah.
What's the wheel for then?
Well, no, because I need to do some of them in order. Like, the only ones I actually need to do in order here are the research Higgs, script Higgs, and then record particle physics. All of the other ones can be done whatever. Role dependent.
Oh.
You know what? Hold on, everyone. I will be right back with you. Give me a second.
Okay.
Be right back. I am, in fact, back.
Hi.
Ah, Higgs.
Uh-oh.
No,
What happened?
no, I haven't. I just need to understand the Higgs.
Oh.
Okay. Elementary particle in the sound of on the field of particle physics theory. In the standard model of Higgs particle is a massive scalar boson that couples to particles whose mass arises from the direction of the Higgs field has zero spin, plus the parity electric charge. Okay, so basically I can just mention the Higgs field, which particles couple with the Higgs field. They then can just weak interaction their way into a Higgs boson, and then the Higgs boson and weak interaction its way to whatever else, which means Higgs field.
Mm-hmm.
Some parallel potential. Okay. Higgs field.
Well.
Yeah, I know. Oh,
You know.
CERN. Oh my goodness.
Oh.
Sure, I don't mind if I do.
Are you aroused by big machinery?
What is the difference? Okay, let's see. Symmetry, like symmetry, is like ship can be symmetrical if it does. Applying a similar approach to weak interaction is, however, not possible to fundamental issue. The theory didn't allow it for particles mass. The weak force, known as characteristic on how to be massless, otherwise fundamental symmetry theory would be broken and theory wouldn't have worked. I was talking about a new quantum field and a special trick. Higgs field symmetry was spontaneous broken symmetry on that present in the equation theory. Budget pencils only 2%. Only for a moment, the pencil would immediately fall, breaking the rotation symmetry direction which the pencil would be pointing. Lack of symmetry was essentially tricked into the picture. Okay. Also, giving rise to particle. Okay. So, the basic idea is, and with me here because it's complicated than that. We, in the standard model, we had some particles that, in order for the model to make sense, had to be massless and massive. It's rendered, which is nice. Where are we even with the photon? Interaction starts with one electron causing excitation. Then this excitation travels at the speed of light to the other electron, which then causes them to repel. Okay. So right here. First of all, we'd like this to loop, and then we want it to travel. This is going to take absolute ages of rendering. But this will look good, so who am I to say?
Oh no, you only have to do 5 other things while you're rendering.
How out of character for me. Massive. W and Z boson. Simplified standard model so far is correct. They had to be massless. Then if the standard model was correct, that means they had mass. This led to interactions in the standard model, which proved it, and part the standard model said that they didn't have mass. It's a problem because the exact thing proved that these bosons existed relied on them having mass, but the theory didn't have a way to give them that mass. Makes sense so far? No? Yeah. The issue. And the solution was the Higgs field. Basically, certain particles can couple with the Higgs field and as such gain mass. This is the source of mass, effectively completing the model. The reason why Higgs is always put on the side is because it's weird, to say the least. Make it. I love your vids. They're so good. Oh, thank you, Ted Bot. I appreciate that. I'm glad you like them. We'll keep making them. I am, in fact, making them right now. Quite literally. The reason is because weird to say the least. It's the only boson that is not a carrier particle for a fundamental interaction, and the way it's most often, but it still mainly functions just like a carrier particle, just with a lot of energy. So for example, if two protons... I don't like that example. I really don't like that example.
Doing the better example?
Yeah, I do, because I have one example, but it requires two protons to decay, and one of them has to decay into an up, which is wacky. The last chemistry video you gave us was a choice to go for some chemistry. Was one picked? Yes, one was in fact picked. And funny enough, that's the video I'm working on right now, Bot. This is what it looks like so far. The route picked was particle physics. That was the next video picked. Which is this right here. Right here you can see one electron, another electron, and this wave in the back is the photon mediating the interaction between them. Oh. I need some music for this stream. Personally, I've gone organic, but that's also good. If I remember correctly, there were 6 votes for particle physics and 1 for each of the other options. So this is one that wild majority.
Mm-hmm.
This actually, this reminds me, I have so many things to do that I should have done a while back ago. First of all,
Like me.
shut up. Genuinely, I feel like I still have my cat and I'm just yelling at them when they were meowing during a live stream. Okay. First things first, it's a bit of an art, but oh well. If you've... No one has been wondering why there's no videos job, but... Okay. 1/6 of the largest video made is basically finished. Preview is on Patreon. Sorry for not uploading for the past weeks, but this video is taking a lot out of me. Still, the next particle video, particle physics, should be up in about 3 to 4 days. If I keep going at the pace I'm going, then yeah, it should be. Let me just pick some kind of fun.
Oh, if you keep going.
I just can't stop. Cropped up JPEG. That is not the.
Is that the one you're looking for?
No, that's just a picture of like me with I cropped some stuff, cropped like the top layer. What are you thinking? You need honesty.
I think that JPEG would go hard. It would go hard. It would also make me hard, and that's I mean,
make it as Gregory House. Yeah, it is. It does have that vibe, doesn't it?
He is.
Hold on. I have. Hold on, Tattoo Bot.
Doctor Apartment.
Where is Doctor Homeless Shelter? Doctor Homeless Shelter. It was in.
Yeah. Yeah.
One. Wait, where's my? Why do I have so many folders? Why do I have a shitpost folder and a shitposting folder? Oh, there we go. This is Dr. Home.
Yeah.
This is the dumbest. It's part of my images that go hard compilation. Into which I should also add the the one we're just sitting because that's just a good looking one. There we go.
How about the one with couch?
No, that.
Why not?
We're sitting on Patreon just to find out you have commissioned for a drawing of me milking you. Pigs, okay.
That's one thing. Another thing is that the All Metal actually made it.
You pay, of course they made it! It was a commission! Oh yeah, well, that's what I was doing. Higgs particle decay. It's crazy your channel isn't bigger. Well, thank you, appreciate that. Well, that makes sense. I don't engage in It just decays into a bottom quark and it can decay directly to quarks.
Of course. Why wouldn't it?
The reason, no, genuine, because the reason why it wouldn't is because that's something that the weak interaction should mediate. At least I think. Okay, just Higgs particle decay. Decays of a standard model of Higgs, yes. Right, so strange. Okay. I feel like going by images, Feynman diagrams, and then going through sources would be. What are you?
Sources that I made it the fuck up.
In this case, wait, is this 2 protons? Is that entire 2 protons?
2 entire protons.
And why are the... I don't know what this website is. Oh wait, on Wikipedia, wasn't there Higgs boson? Wasn't there like Feynman diagrams for the decays somewhere? There was this for production. And then decay. Okay.
Yes.
We can have 2 fermions. Okay. Orbit. This is manufactured like so for example, if 2 fermions just emit a lot of energy. I need to make sure that I'm I also need some higher energy music.
How much higher energy?
Alright, screw it, let's go with this. There we go. What we're looking for is production, yes. Vector boson fusion, okay. Not gluon, not Higgs shuffling, weak boson fusion. Another possibility is when antifermions, 2 antifermions collide. Oh, okay, so 2 fermions collide. The 2 exchange virtual Z boson, which makes the Higgs boson. Going to be the same, for example. Okay, so that's just antifermion. If 2 fermions collide with a lot of energy, they can emit that energy. Hold on, that's I just got the sound in the background, which means the animation rendered. I should just do this.
No.
This will just keep track of where we are on the script. And how the script is actually. The interaction starts with one electron exchange. Then this excitation travels at the speed of light to the other electron. So right here what we need is this just travel to 1.3. There we go. Oh, tattoo. I'm so sorry to hear that. That's horrible. This is exciting the electromagnetic field. Repel. So what's the Higgs field? Basically 7 part. No, they can emit that energy in the form of W and Z bosons, which then can come together to form to produce a Higgs. It's honestly quite difficult to explain and quite confusing, considering how Higgs can be effectively created from any fermions and the weak bosons. But there is one theme tying them all together. It requires a lot of energy. This colliders. In all the their own don't have enough energy to create monster that is the Higgs. Need to give them that energy. That's why the collider is required. And oh my, we've done it. A bit more, I could say that effectively is the entire standard model. Oh, and I just finished the script. Brilliant.
Oh,
Yeah,
let's go.
which means I can actually record it. I'm gonna do one thing though, because
Wait, this is the Money Makers video now?
the what?
The Money Makers video.
Many makers. What do you mean?
You know, the one with the fucking Posh Make It.
Oh, the one I finished the script for.
Is that not that video?
No, the one I finished. Finished the script for the particle physics video. The many makers
Oh yeah,
video.
no, that's the math video. Fuck.
Yeah.
Yeah, that's I see.
And that one, I'm not even jack shit close to finishing that one.
Okay.
Okay, so here's my progress tracker, by the way. And after finishing the script, I just noted down my progress tracker. I just went from 9% of the work I have for this month done to 15%, which means I'm still really far behind, but I'm not as far behind as I was yesterday. Ah? Yeah, that's just still terrible.
Don't call yourself terrible.
Basically, this number, if this is a 0, that means I'm on track. And right now it's minus 0.13. So it's a minus. That means I'm behind. But if we finish up enough of it, then I won't be behind. Which means that right now what I need to do is I need to open up Premiere Pro and I need to record the entire video. And once I record the entire video, that actually should also push me way more closer to finishing. Then, well, we just need to keep going. And going.
Or who?
And going.
Keep going.
Forever ad infinitum.
You keep me going.
Good for you. What's going on?
It's not the song I was hoping for, therefore I'm disappointed.
You know what? In the meantime, I'm also gonna need to slightly. No, oh, I almost fucked up. Oh, I said that I'm gonna slightly change up the mask because I keep like tweaking it, and I don't exactly like the way the skeleton's looking right now. But I realized if I did that, if I started printing, I wouldn't be able to record the video. Oh, I almost fucked myself over. Thank goodness I didn't. Okay. Particle physics. Because now I can
Oh
just...
yeah, because printing is loud, isn't it?
Yeah, exactly. And now we need to wait a whole... It's always better to just rip the band-aid off. So I just need to, right now, record the entire video. Hopefully in one sitting, and then just have it be done. And then I can do whatever I want, and in the meantime just edit and such. Okay.
Alright.
So far, these are all of the animations we have. This doesn't work quite as terrible as I would expect. Well, there's a lot of glitching right here. Alright. Me.
Glitching.
Say.
I like when you glitch in and out of me.
It's kind of like, you know what, just whatever.
You go. I just had to say it before you started fucking yapping.
What's that even supposed to mean? Not even what it means. What is that even supposed to mean? You know what, whatever. I'm just gonna do my thing. Test 1, 2, 3. Test 1, 2, 3. Okay, this is fine. In the past videos of this series, I've talked about basic quantum mechanics. I've talked about electrons, chemistry, bonds, all of those things. In the past videos of this series, I've talked about basic quantum mechanics. I've talked about electrons, chemistry, bonds, all of those things, but I haven't actually explained the basics. The very basics, the elementary fundamental stuff. And so that's why today we'll go over these basics by filling in the elementary bingo containing 18 elementary particles and 4 fundamental interactions. Starting with electrons. So, what is an electron? I'm just gonna record it in segments. There we go. That's the first one. Well, considering how this is a video about particle physics, you could be tempted to think that electron is a particle. And I mean, you're not exactly wrong. It is certainly a particle. But in this case, we'd rather think of them as excitations in a field. So, basically, imagine our entire universe as being one-dimensional. So just a singular line where you can either go right or wrong. These are your only 2 options. For now, I am modeling it as having no particles, so this is just an empty universe, right? Well, not quite, because even though we have no particles, we still have something remaining, the line itself, the field. This field is important because the action of us adding the particle is just excitation in the field, like this. This right here is an electron. This is effectively the psi you've seen in all of the equations. This psi refers to a function, that function being this wave. And that is the big idea behind quantum mechanics, yada yada. I have made way too many videos about that already. What we'll focus on today is the particle physics, however. So basically, we have this excitation. Then what we do is we just assume that this excitation is a particle. Or I guess assume wouldn't even be the right word, kind of by definition. It doesn't matter, irrelevant semantics. So when you hear a particle, you might be tempted to imagine it as a point or a ball, and yeah, this is how I'll be representing them throughout this video. This is how I'll be representing them throughout this video for simplicity's sake. But in reality, this is what particles are. They are excitations in the field. Or rather, that's what they are in quantum field theory. It's, the quanta of the field. That's why it's called quantum field theory, quanta of the field. Okay, I'm gonna stop for now. Make it a much from a sentence message to know. How long is that, do you reckon? I haven't got a clue. He's making it. I am in fact making it yet. 3 minutes already! But to be fair, I did get the script wrong a bunch of times, so that's something. Now with this electron in mind, let's add another one. There we go. We have 2 electrons. Lovely. Now let's bring them closer together and... oh, would you look at that? We've got a bond. From the past episodes of this series. Isn't that just lovely? These 2 right here are electrons in the s orbital. And this is the sigma bond. This is an antibonding sigma. And if you still can't see it, I just can decrease the wave number. Or I can increase it. Technically, the mathematics would be slightly different because I can't do complex numbers in Blender, but this is close enough. I'm working with what I can, alright? What a bond in chemistry effectively is just this. These 2 functions affecting each other, so interacting together. As mentioned, I've already covered it in the past episodes of this series, so I don't want to retrace my steps. What I haven't covered, however, is the interaction between electrons through different means. For example, they both have negative charge, so them repelling each other. Before we get there, however, let's take a look back at our elementary bingo. In this bingo, we have 17 particles and 4 interactions. In our current models, we consider to be elementary. Oh shit, who wrote this script? Honestly, I might have been drunk when I wrote this. It's ridiculous. It's not English language. Before we get there, however, let's take a look back at our elementary bingo. In this bingo, we have 17 particles and 4 interactions. In our current models, we considered... fucking hell, genuinely. Unbelievable. Before we get there, however, let's take a look back at our elementary bingo. In this bingo, we have 17 particles and 4 interactions we consider elementary. And we already have filled in the electrons. Next, it's time to add electromagnetism and photons. As you might have guessed, the fact that electrons must have charge means that they must interact through electromagnetism. So basically they are able to repel each other, and even though we find that behavior obvious and intuitive, we've all seen magnets, it's worth asking another question. How could that happen? How could they interact at a distance like that? Is it magic? Is it divine intervention? Is it just a bug in the simulation that is our universe? Well, no. In quantum field theory, we have a simple-ish explanation, and that is quantum fields. Once again, it's always going to be quantum fields. So think about it this way. When we had our 2 electrons come together and interact, they were still effectively interacting at a distance. The difference being is that distance was really short. So how did they interact? Well, they interacted with the field that they were on. So this time, if they cannot interact with the electron field, because the repulsion happens because of electromagnetism, this means that what we need is another field. The electromagnetic field, to be more exact. It carries the electromagnetic interaction. And the reason why they repel at a distance is because in the electromagnetic field is where the repulsion happens, and it carries the interaction. This is what repels the electrons apart. That's because these electrons can usually interact with the electromagnetic field. So, effectively, the interaction starts with one of the electrons causing an excitation in the electromagnetic field. Then this excitation travels at the speed of light to the other electron, which then causes them to repel. Now, which of the 2 electrons causes the excitation? The left one? The right one? Well, both. And neither. And only one and the 2, if that makes sense, which it shouldn't because it doesn't. It's superposition. Now this covers the electromagnetism of the standard model. But I did also promise a particle. So where is that particle? Well, right here. Just like electron is an excitation in its field, photon is an excitation in the electromagnetic field. And that's why it's called the carrier particle of electromagnetism. It carries the interaction between particles. There are 2 kinds of photons you can encounter. The first one is just light. So basically, you know, light. It's a bunch of excitations in the electromagnetic field. I don't think there is much more I need to explain there. We've kind of all literally seen light. The second kind is the one I covered right now, and that is the virtual photon. The reason why it's called virtual is because we cannot actually measure these photons. They start at one of the electrons and go to the other. There is no way to capture it halfway through. The only reason we assume them to exist is because there has to be something carrying the interaction. And once again, in the quantum field theory, we theorize them to be quantized fields. Simple. Next we have... Holy shit, how is this already at 18 minutes? Okay. The animation finished rendering. Right here, what we need to happen then is... we just need the photon to disappear. Which means we just take this...
Meow.
And then we multiply it back. Yeah, I know. Still reminds me of that meme. Every single time my cat meows, I say I know, but I'm lying to them. I don't actually know. Alright. Oh, this might be way longer than I expected. Quarks. We'll start with just an up quark in its own up quark field. This works in the exact same way as an electron, just a particle in a field. In this case, I'll add another quark, this time on a separate field, the field of a down quark. In this case, the up quark has a positive charge, and the down quark has a negative charge. So even though they are on separate fields, they will still affect each other with electromagnetism, because the up quark will interact with the electromagnetic field by creating a virtual photon. This virtual photon will travel right and interact with the down quark on the down quark field. It's important to remember that in this case, that is still a one-dimensional universe. So despite the fact that I spread them out for the sake of visibility, that doesn't really matter. In reality, this right here would be the interaction again. As you can see, despite being on different fields, they can still interact, because both quarks interact with the electromagnetic field. So now we can go back to our bingo and fill in the up quark and the down quark. But quarks are most well known for their interaction with another field, the strong interaction field, and the gluon. Okay, so going back to our many fields. Let's create a scenario like this. We'll have the strong interaction field, the electromagnetism field, the up quark field, and the down quark field. In this case, we can add two up quarks, so first and second, and then we can add a down quark. Right away, as we add them, the electromagnetic field becomes excited. The up quarks have positive charge, down quarks have negative charge, so right away we're getting virtual photons carrying this interaction. But this time we're also getting gluons carrying the strong interaction. Strong interaction is something that I need to explain on the side, because whilst every single up quark has a positive charge and every single down quark has negative, the charges for the strong interaction can change. So basically, each quark can have one of three different charges, which physicists very conveniently named red, green, and blue. So if we have our three quarks, then our up quark can be blue, for example, the second can be green, the third one can be red. Now the way the strong interaction works is simple-ish. We effectively take the quarks, we take their colors, and we combine them. If the color we reach is white, then that keeps them together. That's it. In order to see more complicated examples of this, we'll need to wait a fair bit in the video, but for now, that's as simple as it could be. That's why if we come back to our three quark example, we'd first have a gluon carrying the interaction between the up quark and the down quark, another gluon carrying it between the up and down, and then one final between up and up. And that's all of them on the field. And all of them on the field would look like this. And there we go, we end up with a proton. Since we have two particles with 2/3 charge of an electron, each quark has a charge of 2/3. Each up quark has a charge of 2/3, whilst a down quark has a charge of -1/3, which is an important thing on the side. So since we have two 2/3 and -1/3, the total electric charge turns out to be one charge of the electron, but this time in the positive. When it comes to neutrons, they have a neutral charge of 0, and that's because they are formed from two down quarks with charge of -1/3 and one up quark with charge of +2/3. This equals to 0, and that's why neutrons are neutral, and protons. Fucking now? This equals to 0, and so that's why neutrons are neutral, and protons are positive. Now this kind of view into nucleons is interesting, but we can take it further. What if we wanted to turn a neutron into a proton? Well, in order for that to happen, we need to do something, probably using magic, to turn a down quark into an up quark. So let's talk about magic. Oh, there we go. This is 12 minutes in, and video-wise, we are at the weak interaction. So we are halfway through. Brilliant. Physics, look outside. Chemistry. I wasn't joking. I genuinely will make a whole video just... This video is such a shitpost. Just tricking physicists.
2 minute shitpost.
Because it is. Like, describing the skeletal structure as Feynman diagrams is objectively wrong. But it's funny.
This is a funny guy.
Superposition resonance. And propagators as transition state reactions, I'm also happy with that. The more it keeps going, just the more and more awful it becomes. Did it render? No, it's still going. That's good. Okay, that's brilliant. So we were at the weak interaction, weren't we? By the way, everyone, I'm almost done with the recording, don't worry. Once we're done, the recording is gonna get much more interesting. In order to perform this magic, we'll need the W boson, who will be our wizard, and the weak interaction, which will be our spell. In theory, the way it works is simple. We start with a neutron, then we use our weak interaction magic to turn one of the down quarks into an up quark, and voila, we've got a proton. This is effectively how the weak interaction functions. It just takes a particle and turns it into another version of that particle. So, for example, oh, that's not true. This is effectively how the weak interaction functions. It just takes a particle and turns it into another particle. So, for example, it can flip a down quark to the up quark field, like so. As I mentioned, magic. This happens randomly, and we will revisit it later on in the video, but for now, let's first tackle the rules. That's because a down quark does not simply become an up quark. It also has to emit a W boson on the W boson field. To be more exact, it's the negatively charged W boson, and that's because rule number 1 we'll learn about weak interaction is it conserves electric charge. That's why if we want to add 1 to the charge of a down quark, we need to subtract it in the form of a W boson. The charge of the down quark being equal to -1/3, so the charge of the up and minus W being equal to 2/3 -1, so still -1/3. Another rule is that the baryonic number has to stay conserved, which effectively just means that the number of quarks cannot change. In this case that's obvious since we're turning one quark into another, but we'll elaborate in the future about how that will be useful. And then finally the leptonic number also has to stay conserved, which effectively just means that the number of leptons has to stay constant. In this case, we've decayed the down quark into a W boson, none of them being a lepton, so the leptonic number stays at a consistent 0 throughout. Now that we've explained this, let's have a gander at what it would look like in our fields. First we have the up quark, and it decays into a down quark and the -W boson. Simple. This is really the gist of it. Now we can get back to our bingo and we can add in the last type of a particle, and that is the neutrino. Neutrino follows a trend that you see down the line as we go in the bingo, where quarks interact with all 3 interactions so far, leptons miss out on the strong interaction, and neutrinos only interact with the weak, which is why they're famous for being hard to detect. This does mean that they can only interact with the 2 bosons, and heck, if we're introducing new particles, might as well mention the Z. Z is just like the W, except it doesn't have charge. And so there we go, those are all the different types of particles. Except there is so much more, and in order for this explanation to be coherent, we actually need to go in a completely different direction. And that's because it's time to introduce the antiparticles. Okay, at the end of the day, the device between sex of natural science, math, physics, biology, etc. is just so that we can get good at specific subjects. At the end of the day, it's just all just math. Okay, yeah, I would agree that, like, there is no hard lines between subjects. I will agree with that. But I wouldn't say it's all math. That's a specifically mathematical view. Physicists would just say that it's all physics. You can't have, like, mathematics assumes certain basic rules of logic, which we assume to be true based on the universe we exist in. For example, one big part of mathematics is that, I mean, you can have mathematics without that if you really want to, but like a big part of mathematics is that basically logical statements cannot prove themselves to be false. Like, if you have a logical statement that proves itself to be false, then that kind of causes a loop, where the logical statement is false, therefore we follow it, that means it proves itself true, and so on and so forth. But that kind of assumes our view of logic based on the universe we exist in. My goodness, we're getting too far into. It's meant to be physics. Antiparticles, that's what we have next. Antiparticles are exactly what they sound like. When you have an electron, an anti-electron is literally just an opposite. That's it. The reason why it's crucial that we bring them up right now is because when it comes to the boson and lepton numbers, they are actually calculated by taking the amount of quarks or leptons and subtracting from them antiquarks and antileptons. That's why if we get back our quarkish decay and the emission of the W boson, this boson decays further, and so looking at the rules, it has a charge of -1, lepton number of 0. So the only way for it to decay further is to decay into a negative particle, like an electron. And then we need to do something to balance out the lepton number. The only way to do that would be to emit an antilepton, but since the charge is already conserved, we need to emit an antilepton with no electric charge. We need to emit an antilepton with no electric charge, or in other words, the antineutrino. Now, I know that I've just thrown a lot at you, but this was actually... this was actually needed in order to explain the weak interaction. So now, to make this easier for all of us, let's go over a couple of examples, starting with the full neutron to proton decay. In neutron to proton decay, we first have the down quarks. In neutron to proton decay, we first have the down quark randomly decay into an up quark and a -W boson. Then that -W boson carries over and decays into an electron and an antineutrino. Over here, I'll represent it another way, and that is the Feynman diagram. This time effectively the same animation, except the time goes this way and space goes this way. So we start with a down quark, then as we keep going it decays into an up quark and a W boson, which decays into an electron and an antineutrino. The charge on the very beginning is -1/3, then it's 2/3 -1, then it's 2/3 -1 plus 0, so it's always constant. The number of quarks doesn't change, the number of leptons doesn't change. All of the rules are followed. And so here is the third and final representation, this time with quantum fields. Simple. Then let's look at another interaction, something like an electron with an anti-electron. In this case, the two collide together and they create two photons. These two photons can recombine again, get back the electron and an anti-electron. Here's what it would look like on a Feynman diagram. We start with electrons, they annihilate into photons, and they create them back. Now a curious thing could happen in this case, where as these photons are going, they can actually annihilate again, and create again, and again, and again, and basically if you start with a propagator, end with a propagator, you need kind of a way to combine all of the probabilities in order to figure out if this happens, and that's a story for a Feynman diagrams video. For now, let's just take a look at what it would look like with fields. Simple. Now, another interesting thing that can happen is we can restart our universe, and then we can add in our electron and anti-electron. Now, even though these two look the same, if you look closely, you can see that the left one is actually opposite of the right, which is why when they come together, they leave a blank line. If I actually leave both of them intact on separate fields, you can see it better. Now, if we get back to our electron anti-electron and jack up their energy, and more, and more, and more. Okay, no, I take it back. That might have been actually a tad bit far. Let's back it up a bit. In this case, if we take these really high energy electrons and annihilate them, we get a really high energy photon. This photon can once again create some leptons for us, but this time it will create muons, which will open up a brand new world of particles in higher generations. And actually, comically enough, there isn't much for me to say about higher generations of particles. Like, they just have more energy and that's it. That's really it. We have the strange charm top and bottom quarks, the muon tau and the muon tau neutrinos, but all of them work in almost exact specific same way as other particles on the same level, except they just have more energy. That's genuine. There's nothing else I can say. Next we have, but that is it for the generations, because next we have the Higgs. Okay, basic idea is, and bear with me here because it's actually way more complicated than that. In the standard model, we had some particles that, the basic idea is, and bear with me here because it's actually way more complicated. In the standard model, we had some particles that, in order for the model to make sense, had to be massless and massive. For example, W and Z boson. To simplify it, if the standard model was correct, that means they had mass. This led to interactions in the standard model, which proved it, and part of the standard model said that they didn't have mass. This loop is a problem because of the exact thing that proved that these bosons existed relied on them having mass. But the theory didn't have a way to give them that mass. Does that make sense so far? No? Yeah, that's the issue. And the solution was the Higgs field. Basically, certain particles can couple with the Higgs field, and as such, they gain mass. This is the source of the mass, effectively completing the model. The reason why Higgs is always put on last on the side is because it's weird, to say the least. It's the only boson that is not a carrier particle for a fundamental interaction, but it still mainly functions like a carrier particle, just with a lot of energy. So for example, if two fermions collide with a lot of energy, they can emit that energy in the form of W and Z bosons, which then can come together to produce a Higgs. It's honestly quite difficult to explain and can be quite confusing, considering how Higgs can effectively be created from... It's honestly quite difficult to explain and quite confusing, considering how Higgs can be effectively created from any fermions and weak bosons, but there is one theme tying it all together. It requires a lot of energy. That's why physicists love their Hadron Colliders. Most fermions of their own don't have enough energy to create the monster that is the Higgs, so you need to give them that energy. And that's why the collider is required, and oh my, we've done it. There is a fair bit more I could say, but that is effectively it for the standard model. There is a fair bit more I could say, but that effectively is the entire standard model. Okay, there we go. That's the entire video so far, except for the atom segment at the end. Hi there, tea connoisseur. Chemistry video, not quite. Not one of the videos I'm working on at the moment is kind of chemistry video, you could argue. I mean, it is chemistry. It's mainly tricking physicists into learning chemistry. Okay, there we go. One last chapter. That's the atom. Okay, there we go. So, I would like to finish this video off with a bang. Finish it off with something incredible, something that I really think ties together particle physics into our real life. And that would be tritium decay. Okay, so let's start with our fields. Those will be the up quark field, the down quark field, the electron field, the neutrino field, the strong field, the electromagnetic field, and finally the weak field. I will put them in this order to make it a tad bit easier, and now let's add the particles. We first start with the nucleus, so 2 up quarks and a single down quark. This will be our proton. On its own, this would result in hydrogen, but since we're interested in the isotope, we need to add 2 neutrons, which means on the sides we add 2 down quarks and 1 up quark, on the left and the right. These will be our nucleons, and right away, if we were to kickstart our universe, a couple of things would happen. First of all, these quarks would become confined, meaning that they would instantly begin exchanging gluons, actually forming the subatomic particles, like so. Next, we have the electromagnetic field, and since our quarks do have charge, we get some excitations on the electromagnetic field. We get some photons. Now, overall, our charge is more positive, which means that it would really like to attract something with negative charge, something like an electron. The electron is stuck to the nucleus via the electromagnetic interaction, and it is that interaction that keeps it in place. There we go. Swell. That is what tritium atom looks like from the perspective of particle physics, in one dimension of course. But there is a reason I picked tritium, and that's because it's really unstable. So if we really want to experience the world of particle physics, we should look at its decay. Randomly and instantly, one of the down quarks can decay into an up quark, or more specifically, it decays into an up quark and a -W boson. This does conserve all of the properties, turning our 2 neutrons, 1 proton hydrogen, into a 2 proton, 1 neutron helium isotope. Then on the side we get the -W boson, which in itself also really wants to decay, this time into an anti-electron neutrino and an electron. This electron immediately comes together with the already existing electron, keeping it nicely. This electron already comes together with the already existing electron, nicely balancing the charge of our atom, keeping it from becoming an ion, and then the anti-neutrino just floats away. It isn't stuck to our atom via the strong interaction or the electromagnetic interaction, so it just keeps going. Forever. And so there we go, that is our atom. If we look back on it, there is a lot going on and a lot of things, a lot of ways, but by now it should all be perfectly understandable. This is the full standard model at play, the best description of the universe we have so far, and a complete overview of all of those forces. And... was that the neutrino came back? Oh yeah, I suppose it must be because of... Yeah, despite being the first most well-known to everyone, I've left gravity for last, even after the Higgs boson. And that's because its carrier particle, the graviton, is a whole other story. Not only is it hypothetical, but also it has some fundamental problems with just the theory. Problems that I'm not even qualified to talk about. So that's why right here I bring in my own personal physics expert. Lord of space and time, since to him they're both the same thing. The master of Taylor expanding, the excitation in the drunk field, it's Remco! Oh, sorry, I have to interrupt you. You see, it seems we've run out of time, so... There we go, 27 minutes. Yes, brilliant. Okay. Katsu, you can get back to it. I'm done.
Meow.
There we go. Yeah. Okay. So far, I am minus 0.13. So far, I am minus 0.13 when it comes to how far behind I am. Now, if I fill in the fact that I recorded the entire video, we get minus 0.1. I am still behind, but not quite as severely.
Woohoo.
Woohoo. The unenthusiastic woohoo is very much... Yeah, that's... Yeah. Okay, where am I with this, by the way?
We're getting there. You're getting closer, that's important.
Which then causes them to repel, which means in this case... No, I'm so close, Katsi. And in this case, all I need, this is the EM field, we need the electron field. And so in this case, we're just going to have both of them move slightly away. Might be too slight. Let's go for 7. This is some wave funkery because they should be oscillating, but whatever. The title hurt me again. Remco, I've recorded the entire video so far, and it's 26 goddamn minutes. Okay, now it's time for me to edit this monster.
Only 26 minutes?
Yeah, it is. Parametrics. I almost wrote particle instead of parametric equalizer. There we go.
How much of the video have rendered?
Actually, this is nice because normally I record the entire video so much later in the video making process. So right now, at least, like in the way I have my progress tracker noted down, I basically have like a maximum amount of points I can get per video. And then I just fill in what percentage of the video on each part is finished. And so since right now I have the script finished, I can tell that I can literally just measure it by the amount of time. It's my... Listen, we all need something to keep us going in life, okay? Since I don't have any alcohol on me, this is the next best thing. Okay, now it's time to just edit and do my job. Okay. Oh yeah, I can also open up SolidWorks and we can do the mask tweaks I wanted to.
Okay.
I can now have a percentage of how much of the video is finished.
Or yeah.
Whoa! SolidWorks jump scare. Piss off, mate. Oh, my PC must love me. I'm Blender... Hold on, because... Well, my taskbar isn't even working for this. That's brilliant. Hold on.
Oh.
There we go.
Well, so do I.
Give it a second, let it... This should be my taskbar on Windows, but Windows clearly very much doesn't want to display it. There we go.
Oh,
I have
no.
Blender rendering.
You're
I
just
have
first.
I have OBS streaming, I have Premiere for editing, I have SolidWorks for designing, I have a whole bunch of Firefox pages. Will you stream even after you finish editing? What do you mean? Like, I don't get that question, Sisha. I got rather quick. Alright. Okay, right here we need this, and we also need alright. The entire video will be just full of loops, so I'll just need to... I don't have a loop of the first fucking thing of the video. Well, that's brilliant. Oh yeah, because on the very beginning they didn't... Oh, okay, because on the very beginning... Never mind. Never mind. I'm correct, it's fine.
Okay.
Ah, there we go. Okay, I'm gonna do it in a way so that I'm actually going to do a full edit from the very beginning. Will you stay live or go to sleep or something? Sishi, I will not be able to edit this video today. Like, this video, at best, I'm gonna be able to upload it in 4 days. That's at best. It's like an optimistic estimate. Oh, by the way...
What do you mean the Remco?
LED big animation is what it landed on. But first things first, I really want to redesign the mask. Because there is the faceplate skeleton. Just don't show again. Fine, just rebuild. Okay. This right here is wrong. Fortunately, because I set it up properly, it will be easy to fix. Because all we need effectively to do is just bring this one higher up, bring this one higher up. It will look silly. Especially since it won't update. Oh. Yeah, it broke. Did you break? What is happening? Genuinely, what is happening? This delete. This go up. We do have them both as a single point. What is your problem then? Instead, how about we? Oh, it's running really slowly. It is struggling. It is struggling with a capital S. I don't know why, but all of a sudden I'm on just such a high to work. I was genuinely ready to end the stream like an hour ago, and right now I am just...
Do I have this influence on you?
I don't know what's happening in influence on me, but I like it. I like the influence. Making productive.
Well, I like you too.
Cool. How am I supposed to react? There ain't the manual for this. Katsi, I'm already married to the grind.
They didn't tell me in school how to be affectionate to other humans. What the fuck?
I didn't even fucking go to school for that.
You went to fucking school. That's different. And that one they did tell you that one though.
One day I'm gonna have to do a sexuality review, and And that could not go well.
What is it supposed to mean, even?
It means exactly what it's supposed to mean. Okay.
Sexuality review. 8 out of 10. Very sexual.
Oh, right, here's where it's messed up. Oh, that's why. Okay. Okay, that's why. So this should work.
What are you making?
This is the skeleton for the faceplate of the mask.
Looks like a tooth.
It does, yeah. I won't disagree with something that's an objective fact. It does look like a tooth.
Yeah. And it looks like a tooth, therefore it is a tooth. As we all know.
Continue ignore error, yeah, and then right here we just need to change.
Meow.
Why is this stuff? You know what? Just whatever. You do you, boo. You do you. I'm not gonna question it.
Me do me. You do me, even.
Is this fine? I don't think so. Or is it? It could be fine. We would actually much rather, probably, for the sake of, let's call it aesthetics, right here, have this carry over on this and be collinear. Just let job.
Your job was with a good bell.
Job was with a good ball, exactly. And then we can delete this. We can have these two be like this. We can have these two. This doesn't have to be. I would rather not have it horizontal, because I prefer it to be aligned to this. Then this and this could be collinear. This could actually break so many more things right now.
Mm.
But that's only if I'm wrong.
And you're never wrong.
And I'm never wrong. That's why it didn't break anything. There we go. So this is what the
Yeah.
mask will look like so far.
Okay. That's good. Just like you.
Yeah, this is literally me.
Yes.
Okay. Alright, so now what I need from this, actually a couple things, because I would also like to reprint the front plate, but this time with, right here some kind of connective, something at the top, because I don't like this empty space. It feels wasteful. Hold on, actually, quick question. Could I, that would be fucking hilarious if I could. Oh, please tell me I can. That would be the most idiotic thing in existence if I actually, holy shit! There's enough space over there to fill the whole ass Raspberry Pi 5. Oh my goodness, that's the most idiotic idea I've had. Oh, yes, I want to. Okay, I don't know if it's the most idiotic, but like top 5, at least. Way more than top 5. This is awful, and I want it now. Oh my goodness, please, I beg thee. That would be so funny. Okay.
Wait, where are you putting your Raspberry Pi?
On my forehead. Because there is enough space. This bitch
Yeah.
is what I'm gonna put on my forehead because because who's gonna stop me? Basic logic.
Your forehead is so big it can fill it.
No,
with an
wait, I
entire
genuinely
PC?
just check. Right here we have enough space to put a whole Raspberry Pi Zero. That's how much space there's wasted. If I actually could
What?
like, I could push it even a bit more forward. Hold on, let me think. The only question is, I mean, it could like be bad for my forehead, not the mask's forehead, but I don't care, so that's fine.
Do you need a heat sink on your forehead to cool your head?
If anything, that would be a nice heating in the winter, you know? Winter is coming, and
Winter is coming in, so do I.
if I do it right, it won't touch my forehead. There isn't a lot of space. There is certainly not a lot of space, though. It would be close, but I like it. There might not be a space for my head, but like, I can chop that off. Okay. Raspberry Pi 5 STL. Or step.
I mean, if you need an extra head,
Katsi, if I ever run out, I'm gonna ask you for a head. Don't worry. If you're willing to give me head, who am I to discourage that?
I don't know why people think we are like a couple. What could possibly lead you to that conclusion?
Maybe the fact that you asked All Matter to draw me milking you. Maybe that. I feel like I could play a part.
Maybe the fact that I'm not gonna say that on the stream. Never mind.
Is the one?
Yeah.
No, this is the one. It could be. Okay. This workshop long-term mask. Oh, this is so dumb. Circuits ready models works. Other, and then right here I'm going to copy this. I'll move here. Go. Is this the one I'm looking for? The girl was watching this, she would be so happy to see all the bromance over here. This is not a bromance. No. See, you misunderstand so much. You clearly don't know what a bromance is. Bromance has like no actual. No, this is the wrong. This is the thing. Bromance would have no sexual implications. All the jokes here have sexual implications. I will not have.
Also, isn't romance between two straight people?
It doesn't have to be, but it can be. The point is, it's non-romantic. That's what the bromance is. Actually, no, it can be romantic. It's not sexual. Bromance would be, for example, bromance is, for example, between me and Tefta. That's bromance, right? That is it.
That's bromance.
Like, for example, I don't know. If the whole world would just go completely tits up and it would just complete apocalypse, everything is ruined. Me and Tefta completely remaking the internet over the span of continents by independently setting up all the infrastructure in place and implementing the protocol that would just click. That's bromance. That's the real thing. Why is my SolidWorks?
What an example.
My SolidWorks is broke. Oh, that's splendid. That's brilliant. Whatever. It doesn't matter. I don't know the drone thing.
It is done like with works.
Okay, I need. Okay. IPI 5, not 4, 5. So is the term for the other gender cismens that? Well, I don't know what cismens is. I am not familiar. Sketchfab. Do you have anything free? Because I'm not gonna lie, I am doing it simply for convenience's sake. Why can you learn effect? Oh, whatever. Sistermans, I think. Bro is a gender-neutral term. All the terms are gender-neutral if they're used by me.
No.
Okay. Oh, here's my school call each other bro. Yeah, because it's gender neutral. Bromance between girls. Don't smash in sex or gender into it. For another example of bromance is between me and Ali. That is a bromance. To me, like,
That's
I would describe it as when you have interactions, positive interactions between people, then there are two kinds, in my personal opinion. That is like interactions stemming from sexual attractions or attractions stemming from respect. And like bromance is the min-maxing for the respect part.
okay. What's the other one called?
I don't know, relation, like a normal relationship, boyfriend, girlfriend, such. A marriage. That would be the other one.
Marry?
I mean, yeah, like that would be the other one.
Will you marry me? Well, I should be the one asking because I'm a girl, actually.
That is so wrong on so many levels. Okay.
What do you mean?
What do you mean? What do I mean? I mean exactly what I said. First of all, you implied that oh my fucking solid was crushed again. First of all, you implied that girls cannot ask men to ask, like, would you marry me? You implied that only men can do that.
Like, culturally. It does fall apart when you have a lesbian marriage. But,
because I'm a girl.
ignoring that part,
No, like, anyone can ask out anyone. And I will not accept your sexist ideas on this live stream.
Oh my god. Yeah, me and my sexy ideas.
Because I'm a girl. Actually took bro time to realize. I don't like your usage of the word bro simply because I don't like kids' speech, but it's funny.
I'm sorry, I'm new to this trans thing. I'm just, I may be stupid. What I'm trying to say.
I'm new to this whole being a woman thing. Give me,
yeah.
Give me a second to transition. It's so funny because that is a genuine usage of the word transition really often, like just to a new scenario. That is so funny. All right, can I import a glib file?
Glib file. What's a glib file?
How do I even import stuff? Because I can drop it in, but when I drop it in, it crashes. Oh! Egg on my face. It crashed a second ago, but it didn't crash this time.
Okay. Mine on your face.
You know what's weird? I've been just having remember the graph I did?
Yeah, move more things.
Remember the graph I mentioned? I'm cooking, shut up. Remember the graph I mentioned recently with the whole, like, my instability? Usually after instability, there comes a period of genuine, like, ennui and mildness, let's call it. And this is the moment I should be in right now, which means either I am still in my instability peak, or it's one of those rare moments where something just threw off my rhythm. Sad.
I have trouble understanding what the fuck you just said.
I said, to boil it down, I get it because I'm cooking. To boil it down, I effectively said that my mental state is. Why is this not there? Is unexpected. Damn it.
Unexpected. So the graph you just made is irrelevant because it doesn't matter.
What do you mean it doesn't matter?
But you're unexpected anyway. Unpredictable even. It's mostly you're crazy or something, you know?
Shut up. How long can you accept that I'm crazy? By the way, thank you, Maker. I saw your post about you not caring about popularity because of the community. I want to say thank you for that. Well, thank you for that. And the whole point was me thanking you because I appreciate the community. Honestly, if being popular without this community would suck. That's not the deal I would take. I'd much rather stay where I am, but with the community I have.
Yes.
So
Actually, you'd much rather stay with me.
The repulsion happens because of a much. Now the field is actually caused by an excitation. Cause the accelerator, the left one, the right one, or both? Neither. Okay, so in this case, what we would like. Oh, this is actually. We could do it with a bit of a longer animation right here. But basically, we could have them start. New file. We could have them start at -1. Actually, value. Math multiply by -1, and in this case this and this and this. There we go. There we go. But we would like the bottom one to oscillate backwards.
Oh. You always love when the bottom one oscillates backwards. What's that supposed to mean?
I was about to just like bash halfway through as you were saying it. I was about to bash you for once again not making any sense, but well, this was actually a good one. No, in this case we need this one too. Yeah. There we go. Splendid. And another thing, we would probably prefer it to be sinusoidal.
I love how you just can't tell whether I am just repeating what you just said or making an elaborate joke.
Exponential. A little back. No. What we want is we want something that quickly increases.
Mm-hmm.
Let me know here. It kind of looks like as I was based on the full coverage of the file, but look exactly original. Okay. Could it be? We need it to be high on the very beginning. No, so we do need it to be Bezier, and then we do need to change in the graph editor. This will be right here. Even better would be if we could. Ah, oh, damn it! I can make group it, never mind. Okay, this could work. But in this case we only need one. Right, there we go. Perfect. Absolutely perfect. And now we can copy this, and the reason why it's important for us to copy it is because that actually gives us the distance. Alright, bye, good God, have a good one.
Bye.
I hope you also smile.
Meow.
Never would do something like this, insane. What do you mean? This theorem is so fucking broken. It proves the finite collection of integration theorems that fall under vector calculus. I don't even know what that means, Ash. Let alone what it does. Okay, in this case what we need is ideally I would have a photon that oscillates between them. So this right here. And then if the photon is going, oh my goodness, this is rough. We can have a, wait now, when we study quantum mechanics. Alright, bye Ash, have a good one. Here's what
Bye, Ash.
we need desmos, and then what we need is, this is actually going to be quite interesting. If I'm not mistaken, if I do a guiding function, like let's say x squared, and then if let's divide it by 100, or let's divide it by 10, just for the sake of it being more convenient. This will be our normalizing function. Then we'll have sine of x times f of x, like this. There we go. What we need is effectively just take a sine wave of the time and this multiply it by this node group. Like this. Oh, why does it go to 0? It's because in this case, shit. This goes 0 to 1. We need it to go 0 to 2 pi, which means right here we also want to multiply by 2. No, we want this to go like this, and then 2 times pi. The photon shouldn't be speeding up, this is the fault of the simulation. Actually, over time we can also multiply it by a lower and lower value. So like right here we still have it be 1, but then right here we'd have it be 0. Okay, splendid. It's going to be a fair bit of a longer animation, but it's going to look good. So, might as well do it.
Okay. You really like liking those pants, don't you?
Are you calling me pansexual again? You know what they say about the swimming cutscene? Okay. this. In this case, there's nothing here. Which is bad. Why does convert GLB to GLB? I am the most confused. Like, there is a mesh, but for some reason it just doesn't appear anywhere. I just don't get it. Raspberry Pi. Okay. I found the file. What? Delete everything. So I crashed again. Splendid. Let me just get the converted file, because maybe the issue is that for some reason all of the models are just at a really far distance away, which would be odd, but hey. Who am I to say what's odd and what's not? I talk to inanimate objects. Bless me. Bless me.
Bless you.
Good. Good datum. Good boy, I mean good girl, I mean good datum.
Good datum.
Okay, back to the mask, yet again we go. I think it's
Have
try
a good
number...
day then.
I think that's a try number 5 if I'm not mistaken. Which bodes well.
Of what?
And that's, by the way, just to get the model in there. All I'm trying to do is just load in the model. That's it.
Hey, you know what they say about trying over and over again?
Yeah, it works. Trying the same thing over and over again, it works. I just have proof right now.
Oh.
This one goes out to all the
Well,
haters.
that is a hefty, that is a juicy model.
Oh, it's very too detailed. But look, it fits! Well, it will. I'm gonna make it fit.
That's what you said.
That is what I said. It might...
I am not incorrect.
It might run into some problems, but not too many. It's could be worse. All I need to do right now is just a lot. Okay, I think I didn't make myself clear. Right here, a sketch. And then this. Oh, goodness gracious me. Oh, great heavens. Oh, great heavens. both of these have to be the same length as this. And this has to be the same length as this. There we go. Why can I still move this? Oh, I can move it because I can move on both sides. That makes sense. Okay. So we have this right here, sketch, which we're going to, as always, extrude by 6. And then, if I go like that, this is going to be quite something indeed. If I establish a new word connection between, if I somehow establish a word connection between oh, even better, I think I could do a USB connection. Between the Pi 5 and the Pi 0, then I could have the Pi 5 do the processing. I could have the I might need to ask on Stack Exchange for some help with this, because this is rough.
Yes.
Shut up. Okay, so cool. How long has this stream been going for?
3 hours.
Not bad.
That's
So
not
far.
that long.
Yeah.
I'm used to your stream joys for 30 hours.
We're gonna need to make this not a really comically long one.
Comically long stream. You're not competitive for anything.
Okay, there we go. I don't know. Forever. I don't know. And in this case, what we need to do is we need to take this, we need to copy it, and we need to create a new file, new part, and that will be the forehead. Jesus, this is comical. This is just utterly comical. Forehead skeleton 4.7.0, and in this case sketch on the top plane, and then paste this in, and importantly everything that you can lock into place. Oh, the one looks not necessary. And their distance is also crucial. Okay, brilliant. So we're gonna have this, which we're going to extrude upwards by 6, on which we're then going to add a circle. There we go. There's another thing I'll need to do. No, it just got me thinking. Yesterday, was it yesterday on stream when I figured out the debug for the
Maybe?
Raspberry Pi Zero? You have no idea what I'm talking about, honestly, don't
I
you?
think I am. You were talking about debug stuff yesterday on stream.
Every single computer.
Okay, I'm sorry. Egg on my face. Meow.
No, it's good.
In the microwave.
What do you mean in microwave? On the stove, you student ramen eating feline?
Okay.
Okay, there we go. It's time for my lunch break, so you can all piss off.
Meow.
Yeah, shut up. Where's my... I'm looking for a live stream. Shut up! Okay.
Voices in your head. The cat, the stove, and the 3D printer.
In real life. $48.29. Remember that, Katsi! Don't you ever forget it?
Don't worry.
You already forgot, didn't you?
No.
What was the number then?
I am very good at remembering the last thing you said.
What was the number then?
It's 48.29.
Yeah, good, correct. I was testing you. You can forget it now. I don't need the number anymore.
Oh, can I have it?
No. It's mine. I want it. I take it back. I want that number.
What the fuck?
Hi, Lewis.
Too late.
How you doing? Oh, no, goodness. I don't even want to think about what happens when the shit hits the fan.
Oh no.
Okay. You can turn this off as well. We can turn this off. We can turn this off.
You can turn me off. Oh no, you can't do that one. Never mind.
I can. I believe in my abilities. Okay, here's what we're going to have. We're going to have this. What does the pie look like again? Yeah, by the way, this is my lunch break. I am having right now my lunch break, in fact. As everyone can clearly tell. What is he doing? I am designing at the moment. This. Then we will want the angle down, I think. Like this, like this. Like this. 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 go, and then oh no, because we needed to. Oh, why is this so difficult? Right here actually is where we needed to.
Making. Fuck. See, I supposed to make. I say mating. God damn it. Okay, let's try that joke again. Make it finding the sound effects for the next video. Just like me. What?
The edge like this. Sorry. This.
I can't believe I called you mating.
The way actually our brains understand words is curious because they either understand the words by how similar the words are, or they understand it by association. So
Okay, so which one is it?
So yeah, so for example, sometimes you wanna say, I don't know, croissant. This is gonna be like a very weird example, but like I don't know, you wanna say an orange, but instead you say fruit because you answer by association. So in this case, which one was it? There's a question for you. Answer.
Okay.
Okay. This will be the very basic.
I will leave it as an exercise to the viewer.
This will be a very basic and rough sketch of what the holder will look like. If we exit it right now, and if we extrude it down by 2, then it holds. We are also going to change it up ever so slightly. So right here we are going to do these lines, because I forgot they have to be attached.
The lack of symmetry bothers me greatly.
Yeah, because this is just the basic layout. There we go. Because I need to test if it didn't mess up the connectors on the sides for its skeleton. Ooh, they are meant to go inwards. I might have actually messed them up.
Uh-oh.
That they have to go inwards. Yeah, this won't connect.
Well, you'll have to mess them back down.
Yeah. Okay. In this case, the reason why I didn't connect is because right here in the sketch, we need these to be for construction, and we need these to be for construction, and then we need them both to point.
Can you just flip the part 180 degrees?
No.
No. Okay. Meow.
Okay, then cool. Now it's gonna break everything. That's why we need to fix it now. So this right here, I imagine the issue would be edit sketch plane to this one, and then edit sketch. So oh, this one fixed. Now we need to tackle the other ones.
Wow.
There we go. And then finally this, which we're just going to there we go. This is how it's meant to in fact work. And now if we go back to the mask, if we break the selected mates, and we restart it also this here, here, and finally this right here. It's fine. Just need this. This. And there we go. Right here is where we'll have our Raspberry Pi 0, which means it needs to actually go lower down. Gotcha. Okay.
Meow. How is your pasta?
What pasta?
You don't eat pasta?
No.
What the f? You only eat pasta? What are you talking about? What are you eating?
Vegetables.
Oh, okay. Monsters. How do they taste?
I'm not much of an energy drink myself, guy, you know? Not really into energy drinks.
Yeah. That's what I was asking.
Okay, there we go. Then what we need is all of these. Be
Meow.
equal, and then the rectangle like so, in which midpoints same spot, vertical, trying so slowly. Close, that's correct because it is broken right now. Yes, thank you for pointing out. This broken, and then select midpoint to this. Make it. Do you eat anything other than vegetables? Let me think.
Me.
Well, that reminds me. I drink milk. I do drink milk.
You do drink milk. I can confirm that.
Shit. They're cheap on matter, right? They're cheap. I like them. They're cheap. Why is it selecting the line? Select the midpoint. There we go. Brilliant. And there we go.
Yeah, Mike is quite fond of my milk.
And it's comments like these that make me want to just not eat anything at all. Comments like these that take away my appetite. Okay, beautiful. Hello, it's my first time on one of your charity streams. Love your content, man. Thank you, Random Promedio. Thank you. I'm really glad you like
I'm
it.
sure you will love it here.
Tap, Tatsi. Don't worry about them, Random Promedio. This is just, don't worry about it. What are dimensions?
You're not like those people.
Dimensions... Raspberry Pi 5. Check Discord, I'm bored. Oh, what have you done this time?
Oh god.
I might have yet another commission for you, Almaty, actually.
Oh.
Because I always have yet another commission. Let me see the art channel. Why do I look so...
That's pretty good. He looks so fucking sad. You know you're about to end it all in that picture.
Motivation art. Are those tears on the side? No, nice attention to detail.
Almater, I have one request. I'm not gonna pay you for this, so do it whoever you feel like or no. But like,
don't do it because I already
no,
said
no.
even for money,
It says,
your requests aren't valid.
well, I think it's a bit more valid. Take the last art you've made, you know that one, and just make it, because I look very stoic in that one, and I just wanna the one that's just me.
Wait, but which one? Which one are you talking about?
You know, the one of you and me that I commissioned.
The cow, right?
Yes. I want the one that's just the cow.
No, I'm not gonna do it, but let's hear it. It's just... You do realize, by the way, it's not just like take out, make it. I create not many... Unless this is
What
actual
is it?
layers, then you do realize that Almaty would have like draw the rest, right?
Well, like 80% of the pieces are already done, which is why I was, you know. Listen, I'm fucking broke. I cannot spend any more money. I'm going to hate myself so badly if I do.
Been there. And speaking of, I will have another commission for you, Almaty. Because, well, I need it for videos, right? All of the commissions, I need, it's a business expense. I need it for videos, it's important. You don't understand. But the shirtless ripped naked is crucial to the video making process, and I need to spend my money on that sort of thing.
Shirtless ripped make it, so it's just make it.
Well, the shirtless, yes, but like the ripped, well, let's hold ourselves. I have a scientist physique. Can I get any subtle hint? I think I can just straight up tell you. Basically, I plan on making another video that's gonna be a bit lighter with me and Remco. Basically, where we would like just talk about different kinds of Feynman diagrams and more other interactions between particles. But I want that video to be a lot more casual, and as such, what I would need is, you know how in the corner I have the Discord reactive make it? I would need this sort of thing in the corner for me and Remco. That would basically be it. In the video I am going to mention it's your art. because I still feel bad for all the free stuff he did. Where's the dimension I'm looking for? There isn't there. Okay, it's 49. 56. 56 is the full one. Then it's distance from the end is 7, which means it's 56 minus 7 times 2. That's 42. There we go. Then you have to go back. Can't wait. Neither can I, but unfortunately I need to complete a whole other video before I get there, so that's why I said soon. But now, unfortunately. Equal, very much not equal, parallel. Totally parallel. Parallel. Then ideally we would like to these to be parallel. Then we would like distances between them to be more constant. Goodness, it's running so slowly. Cassie, what are you tippy tapping away over there?
I'm tippy tapping. Hold on, I'm not finished tippy tapping.
How to make science look so easy, man, so intelligent. It's kind of the only skill I have. I often mention I'm not a chemist, I'm not a physicist, I'm none of those things, but the one thing I can do is just at least make it reasonable. Or at the least I try. Okay, if we remove both of these, then I suppose we should be able to move the entire thing down. The question is how? Do I just... Great. I would even say that's not great at all, right here. Would we rather... You're not, that's good, yeah. Don't be. You also should be horizontal. And that's because I want you both to go down. I know it looks really wonky, but this will be the basic idea so far. So shrimple.
Not so shrimple now.
It is really shrimple.
Is shrimple?
Damn it. I couldn't spell it backwards.
No.
Because there isn't a lot of wiggle room over there. Okay, another thing is that these squares, let's just fix it one problem on it. These squares have to be much, much larger.
My holes aren't circular anymore.
Okay, there we go. Then what we would like to happen is... Actually, could we... I have an idea. We're going to completely remove the sides. Completely remove them. Then we're going to set this and this to be equal. And supposed to be on the same height. There we go. I'm going to extend these. They are on the same level. And then we're going to connect them like so. So that these will be on the same level as well. There we go. Now, this should be entire skeleton without the attachments, but still the entire skeleton basically defined. That's a good sign. That's a really good sign. It moving as a unit is a really good sign. Then we can take this and we can actually define the full construction. Okay, now we can connect it. So. Oh, it's so slow. So unbelievably slow. Like this, there we go. Now, if we get back to the plate, there we have it. Right here we're dealing with it backwards, or upside down rather, which means we actually want to move it higher up. Like this. And it also means that right here, what even is this line? Oh, it wasn't attached to the... What is this line? Oh, whatever. To wrap. So, even better actually. There we go. Now let's see it. Exactly, it's overlapping with so many things. Could install it backwards. But that would be... The problem is that right here we'll need actually one more thing. Right here what we'll need is the lights holder. From the previous designs, where's the lights holder? This... No. This. This is what we need, pointing outwards. There we go. Right here we can take this, we can remove the mate, and then we should be able to... No, we can't rotate it actually. Yeah, that makes sense. See, we can't rotate it. But if we move the face... Damn it. Could we move it some more in? But even then, it's obstructing the lights, which means it has to go higher up. But it going higher up is actually doesn't have to be that big of a deal. If we can manage to move these two, why can we not move them lower down? That is my question. This higher up. Go. Then we can extrude, cut it open, and this open. And the reason why we do such a thing is because what we can do, but once again, risky maneuver, is first of all way further, and we also need this to go way further. Why is because right here we can edit the feature that's not going this way, it's going the other way. This.
Mm-hmm.
Now, the absolute mess that happened in this geometry goes beyond me. Because this cut very much should just cut through it. It could be because the sketch doesn't realize that it's on the same plane. What is happening over there? Why is this overlapping? This should not be overlapping. Bollocks. I could just remove everything else. Move this sketch to a... Move this sketch to the top plate. Then from the... I'll fix it.
Yeah.
No, I do need to somehow fix it. What if I... edit the sketch plane? Go onto... ignore error. Oh, goodness gracious me, maybe don't ignore the error. Okay. Instead of defining it with these points, let us instead fix them in place. There we go. Now, as far as I'm aware, it should be in fact completely defined. Oh, this line isn't it. There we go. Now, if we save this and if we change the sketch plane to top plane, it looks fine. Right here, this we can delete. Then it looks very much fine. So now we can delete both of these. And delete these sketches. We can delete the boss extrude and we can delete the last sketch. And there we go. The reason why this is better is because this would allow us to effectively add in the sketch in the exact way we want, which if I'm not mistaken should be from the bottom like this. I'm not even going to bother to define it more properly because I'm pretty certain this is already spot on. And we want to extrude it by 6. Do we actually want to extrude it by 6 or do we want to do it by 4? If we do it by 4, then we would need on the other side some place to nut. Without the nut, how are we gonna screw it in? Which would mean like an opening would kind of get in the way. Could be worse. Yeah, let's change this instead of a 6 to be a 4. Not for A and 4. There we go. And then we can add in circle like so. Okay, this sort of thing. And the same exact idea on the other side. Absolutely, utterly brilliant. If it's not one thing, it's another. What is it this time? What is that noise? Sorry, what the? And just stop there.
Meow?
Fine, whatever. Continue with no error. What is the real problem this time? On the other side. Not in fact restart the thing. I think my neighbors are drilling. Okay, there we have it. That's brilliant because now all we need to do is right here create an opening for that. Like so.
Shut up, correctly.
Shut up. This, and this all parallel. This, and this all parallel. And then the midpoint. More specifically, we need a line connecting the two midpoints. And we need this line to be Can it even like figure out what to do in this case? Oh, it can. Splendid. It doesn't have to be that big. It can be a bit smaller. Okay, imagine it's what, 8. Eight by 3. There we go. Brilliant. And then on the other side, we need to exact same trick. One, two, three. Not equal, only parallel. 3. Select me a midpoint. And there we go. Have a little bit less space on one side. Does bother me. Because that means right here we need to reduce it something like 2 millimeters. But then we're running on space on this side. Well. Ideally we'd go to 0, but if we go to 0 then we have absolutely no space for anything. So this is going to be a bit of a awkward fix, to say the least. And then finally, one last thing on each one of the vertices, we just need to create which, if I'm not mistaken, does our M3s. Not mistaken. Right, let me see. Eyeballing it, it looks like an M3, and if it looks like an M3, if it talks like an M3, then it's not an M3, it's actually an M2. Okay, which means we should change it up. Still being a 4,
Yeah.
we should have it be a 3. And instead of it being a 6, oh my goodness, how did this break absolutely everything? You know what, fuck it, leave it as a 6, I don't care. If a 6 is what you want, 6 is what you'll have. Now if we get back, right here, these mates are completely broken. It's fine, because if we make them huh? How is this? What? I'm so confused right now. This and this. Wait, yeah. Closer. This. Then on the other side. How are these misaligned? Why are these misaligned? Didn't change any of the underlying dimensions. How are they so badly? Oh wait, did I plug them in backwards again? That could be it. Please tell me that would be it, because that would mean I don't need to spend an egregious amount of time fixing. The most annoying process is when you have two different models that need to align. And so you just need to go one by one. Dimension by dimension, figuring out where it went wrong. There we go, okay. That's brilliant. And as you can see, if SolidWorks comes down for a second, it fits basically about as perfectly as it can. It won't leave much of a space for my forehead, mainly because of the lights, unfortunately. So unless, and even with the lights, I guess that would mean that we need to move the visor down. That would make it the word interesting comes to mind, but painful. Appropriate. It is right here on the perfect level. Why'd you start making videos? Just curious. I don't have much of an answer for you there. I just wanted to make videos and I was making videos. Just the entire story. So push this in. Can I easily push it in further back, or will it? So if I increase this to, let's say, 10. Height is clearly off, but that's to be expected. Because I'm pretty certain they are the midpoint, right? Yes. And in this case, we wouldn't want them to be to the midpoint. We 3 millimeters away from the edge. Not all of them. There we go. Millimeters away from the edge. And the nice thing is that the reason why I set up such a long animation to go in the background is precisely because I knew this would take a while. There we go. Just right here, that's free. Opening. Now this should give us a lot more space to play with. This. Sorry, what are you mated to? Oh yeah, that's that. No. 21. These have to.
Good for them.
This right here has to go. Another one of them too. Centric. Break automate. Oh my goodness, how many did you break? Why are these not even? What? How? That's my only question.
Are we not odd either?
Why is the size different as well? Apparently this is as good as it gets. That is really odd. That is just... That's one of those issues I mentioned previously where once the measurements are off, it's really difficult to fix it. And suddenly, why aren't they different size? So right here, what is this called find? Oh, it's not. Oh, it's defined like absolute garbage. That's the issue. Right here, this has to be a 4. I'm guessing all of them are just another. Why is it just also 3 of them? Why is this responsible for 2 of them? Oh yeah, because they are on a straight line. No, that does make sense. This right here. Proper. Okay, there we go. Fortunately, that was just a simple oversight, which means right now, if we get back to the mask, if we, yeah, already it fits in perfectly. Wait, no, that's the wrong one. 8. Centric. There we go. This would be the mask so far, and hopefully this will leave enough wiggle room for everything to fit in. It's a lot more tight, let's just say. Isn't much room for error.
In the first time.
Right here, if we take... Oh, goodness.
Meow?
Going to do...
Okay.
Oh, jeez, yeah, no, I'm just gonna remove the Raspberry Pi 5 model. Okay, well, this is what we have so far. This is what it looks like. I think I'm gonna go now because I am exhausted. It's been 4 hours, no wonder.
Alright.
So I'm gonna go. I'm going to I'm gonna rest a bit with just rendering in the background, nothing too serious. And then I'm going to actually start working on the second chapter of the mask video today. That's fun. And once the second is finished, it's going to be way easier. So, once the second is finished, the video will be done in no time. And for now, that'll be it. Thank you everyone so much for watching and have a great day. Bye!